Starbucks customer in Florida was just in the news because apparently when he ordered a grande white mocha, the barista labeled it "Diabetes, here I come."
Good night. We return to the Hampton Inn JFK on the 12th floor. And we're on the amazing 5x12 matrix, and we've been doing applications of this 5x12 matrix. And in particular, we are using the 5x12 matrix to enhance solutions to mesh circuit analysis. And in the last session, previous, we did some 3x3 mesh analysis using 3x3 matrices. Today, or tonight rather, we are doing 4x4, which is a little bit more intricate. But what we'll do, we'll use the 4x4 and convert it to a 3x3. And since you already did the 3x3 to the detailed solution, we'll convert the 4x4 into a 3x3, and then henceforth we'll have the solution to the 4x4. All right. A couple of sessions ago, we calculated delta for this 4x4 mesh circuit, and we have not shown the 4x4 mesh circuit in this video projection. We're only showing the results. And let me just write down the results once again. We found delta to be equal to 1368. And we found I1 to be equal to negative 163 point something, 0.1 something voltage. And we found I2 to be equals to negative 20 amps, exactly. And now we're going to calculate I3. And we know say I3 is equal to N I3 over delta. And delta is the same 1368. And then I3 we'll found now by replacing the third column of the delta matrix by the voltage value. Let's do that. So we'll replace now the third column. The delta matrix now was equal to 12 minus 2, 0 and 0, minus 2, 6, 0 and 0, 0, 0, 5 and minus 4, and 0, 0, minus 4, 7. I will place now for I3 the third column by the voltage value. Now the voltage value was now, let's write out the voltage here. V1 was minus 240. V2 was minus 120. V3 was 500 volts, and V4 was minus 500 volts. So we place now for I3 to find the numerator value. We say now that N I3 is equal now to the determinant of 12 minus 2, 0 and 0, minus 2, 6, 0, 0. I will now minus 240 now, minus 120, 500, and minus 500, and now 0, 0, minus 4, 7. So we find the determinant of this matrix, and we'll get the numerator value. Okay, to find the determinant of this matrix, let's say this is now, we choose one of these column, anyone, and to find the determinant in I subscript 3. And then we'll say now that I3 will be equal to N I3 over delta, which is equal to delta value is equal to 1368. All right, let's, I don't know, let's strike out the first column to find NI3. So we say that is now equal to 12 into 600 minus 120, 500 minus 500, 0, 0, 0 minus 4, and 7. Minus 2 into minus 2 0 and 0 minus 240 minus 120 rather 500 for this one and minus 500 and 0 0 0 minus 4 7 0 minus 4 7. And the rest would now drop out because 0 multiplied by anything would be 0. No matter what is in this matrix, 0 multiplied by anything would be 0. And this one will also drop out. So we'll have now that Ni3 would be equal to 9. And this is in turn equal now to 72, 12 times 6, 72 into 500 minus 500 minus 4, 7 plus 12 times 0, 0 into something here, which will turn out to be 0, plus 0 into some voltage here again, which will turn out to be 0. So in effect, we'll be left with 72 times this Ni3 will be equal now to 72 times 7535 minus 2000, which is equal now to 72 multiplied by 1500, which is equal now to 7200 multiplied by 15, 15 naught naught, 15 naught naught, 15 2 is 30, 15 7 1, 105, 108. And therefore we say now that I3 is equal now to 108,000 over 1368. And let's use a calculator to determine that. Let's try to find a calculator here. In the meantime, this is being activated. Let's see. So I3 is equal to 108,000 over 1360. This is the first time we get in a positive current here, so that we are saying now that I3 is really going in the right direction. We assume it to be going clockwise, it's positive, so indeed the direction is also correct. Notice that in the other two cases we have found I1 and we get a negative value, so that we assume I1 was clockwise, so that in effect I1 was anti-clockwise. Likewise for I2, we got 20 amps in the negative, so it is going in the anti-clockwise direction. We get I3 to be positive, so it's it's going in the clockwise direction. And let's do calculate I3 to be 108,000 by 1368. We'll find our calculator, and we say now that 108,000 divided by 1368, and that's equal to 78.947. It's equal now to 78.947 368,421. 368,421. And that's amperes, and that's positive. So we're saying now that once again that these, let's try to project it here a little bit. We're saying now that these decimal points would be significant when we are doing small signal analysis, once more, in the picoamperes, 10 to the minus 12, nanoamperes, 10 to the minus 9, microamperes, 10 to the minus 6, and milliamperes, 10 to the minus 3. But right now, we're just doing amperes, so it's 78.947, close to 79 amperes here. And it's going in the clockwise direction because it turned out to be positive. So we're going to calculate I4, and then this will close off our calculation for the current. We could also calculate some power. I say power for this would be equal to voltage times current for mesh 1. Likewise for mesh 2, voltage times current power, and so on. So let's take a break, and we return to calculate I4.